All right, cosine law. So far, you're able to solve for any oblique triangle using sine law. But what if, page 15, what if you don't have a pair? What do you do then? 15, for the 15th time. If you're given the following scenarios, we need to use cosine law, right? I'll basically tell you this. An angle and two sides, two sides sandwiching it, I wanted to say, but I don't know, two sides on either side. Okay, so basically, if you have a triangle like this, always make it off-centered a little bit. So if you have, pick any corner you want, okay? Any corner on this triangle. I'm going to pick this one up here. If you know that angle here and both sides here, that's cosine law. Because guess what? You see a pair out of this one? There's no way to even get a pair. So this is cosine law. Sometimes we refer to it as SAS, right? Side, angle, side, right? You've got two sides and the angle in between. If this helps you, sure, write down SAS. The other scenario is, this one sine law cannot at all tackle. You know you're stuck with cosine law is when all three sides are given. This is called a side triangle in some textbooks, right? If you look carefully, neither one of those has a pair. There's no pair that you can get. Some of you might say, well, Mr. Dixon, look, there's a pair right here. By pair, I mean angle side pair. Okay, there's nothing to be had here. You'd be in trouble. So that's why you need the following formulas. I would tell you that, yes, your formula sheet has these, but they will not be the same as mine. They will look different. And so I would like you to write them down. Okay, so this is when I use my red pen. I will give you, pay close attention to this, I'll give you 3 versions of the formula, but they're basically all the same. They're just looking at it from a different perspective, okay? So let's say you have an SAS here. Like this is the scenario you're after. All you would be able to solve for is that side right there at this point. Okay, so I start with this. A squared, it'll look like Pythagorean theorem at first, is equal to the other two sides squared and added. Okay, and then this is where it changes. Minus 2 times B times C times cosine of, here's my red pen again, of angle A. And for this one, I'm gonna say this is the side A here, and this is your angle A right there. So pay close attention to this one. It is assumed that in this scenario, you would know these two and the angle as well. So everything on this side of the equation, you would know what it is. Okay, so in this, if I look at this formula, it's like, oh, I know B and C. Where's B and C? It's right there. And I know this angle, it's right there. So it's SAS here on this corner, which allows you to find the side across over here. Okay. Let's rewrite this one more time. Let's assume we have the SAS happening up here. So you've got this side, and that angle. That would allow you to solve for this side right here. So this is how you would rewrite it. B squared is equal to, what are the other two sides that are left? If you're trying to find B, you know C and A, correct? So you will go A squared plus C squared minus 2 times, what's the pattern? You see a pattern here? Look it up here. We had B and C, and then it came back here multiplying. We have A and C, so we will multiply A times C, and then we'll go times cosine. Cosine of what? Angle B, right? Yeah. Let's rewrite C. So let's imagine, you got to come with me on this journey. Let's imagine you've got side, angle, side here, which allows you to find that side over there. Then you would have to write it out like this. C squared is equal to, what are the other two sides that are left? A and B. So we go A squared plus B squared minus 2 times A times B cosine of C. There you go. 3 variations. You just need to know one of them. I will just make a note underneath. Oh, let me zoom into that part because we're just dealing with that for now. There you go. Note, you must use the square root button to get the final answer. At one point, you're going to have to take the square root. Go ahead. I want to stay for that second one. And then, so this is for SAS. So on your formula sheet, on your study sheet, you go SAS. Don't write down all 3. Do not do that to yourselves. Just do one of them, okay? Because the pattern is the same. So I would just do one. I wouldn't do all 3, to be honest. Let's go to the other one, side, side, side. Oh, is this scary or what? Back here, this is saying 2 times this, times that, times cosine of A, right? This is all multiplying back here, but don't fear it. If you have a decent calculator, I'll show you it's not that hard. It's very easy to type in. I shouldn't say very easy, but it's doable, okay? There you go. Side, side, side. That means you know all 3 sides. You get to pick which angle you want to find. You get to pick, right? So I'm going to pick, I want to find A first. So this is how you start. Watch this. It's a variation of this formula that right next door here. Cosine of A, you're going to start with that, is equal to, make a long line like this. And at the top, you're always going to have 2 sides adding and 1 side subtracting. Plus minus, always. The first one I want you to write down is the side that's across from angle A, which is side A, correct? So you put that over here, you square it. And then you take the other 2 sides, whatever remains, in this case it's C and B, you just go ahead and write it in like that. And then the denominator, you go 2 times that side, C, times B. That's the formula right there. This would allow you to solve for angle A. I'll do another one. Cosine of angle B. I'm going to tell you it's plus, and then it's minus. What are we going to put here? Which side? The one that's across the angle, which is in this case a capital B. So we're going to go lowercase b, but make sure you square it. Everything at the top is squared. So if B is taken, what is left? C and A, or AC. So I'm going to go A squared plus C squared, like that. And then it's going to be 2 times A times C. That's your second version of that formula. Last but not least, cosine of C. Maybe you can do this already without me. I don't know. Plus, minus, I'm going to go C squared, because that's the angle that I'm trying to find, so I have to put the C here. And then it's A squared plus B squared, 2 times A times B. Page 15. This is so critical. If you don't put the right number here at the end, you're not actually going to find the angle you're trying to find. Okay, that's why it's critical. Write down a note here. Note. What do you think you're going to have to do to find the angle? So a sine inverse for sine is going to be cosine inverse for this. You must use cosine inverse to get final answer. What's the only time you're even going to consider using one of these? When you have all 3 sides. Okay, that's the only time you're going to even consider using this. If you have 2 sides that are sandwiching the angle, you're going to take one of these approaches. Okay? Just 1 second. Just give me a moment. I'll just get you started. I'll get you started. Okay, let's do an example here. Page 16. So for tomorrow, your job for sure is adding one of each onto your study sheet. She already asked earlier. Yeah. Okay, let's do one example and then I'll get you to practice. So calculate the length of side A. So we're going to use cosine law to solve for side lengths. Okay, so here we go. You've got the side, you've got another side, and you've got an angle in between. This is what I would call SAS. Okay, so automatically you would say, okay, this is the side that I'm wondering about. So let's write out our formula first and foremost. A squared is equal to B squared plus C squared minus 2 times B times C times cosine of angle A. And so now we go A squared. Now we're going to substitute. B is 7.9, so we go 7.9 squared plus 5.2 squared minus 2 times 7.9 times 5.2. See how that pattern goes? The 2 sides you've squared and added, they come back here, right? That's a pattern. times cosine of angle 43 of 43 degrees. Here's where your calculator skills come in. I'm gonna do this already. Watch this. I'm gonna write down a, not a squared. Why can I do that? Because I'm already gonna take the root of the other side as well. I'm gonna get one number out of this thing. Okay, just one number. I'm gonna clean that up. So grab your calculators. And so you kind of have to figure out your calculator. That's crucial today. So 7.9 squared. I have an x2 button. I don't know what you have, right? Plus 5.2 squared minus 2 times 7.9 times 5.2 times cosine of 43. You're telling me you're entering the whole thing? Yes. If you do it this way for trig, it's going to save you a lot of grief. There's one problem if you don't do it the way I do it, which I have to talk about a little later. But let's all hit equals and see what... Never mind. Let's try this again. So square them. Minus 2 times 7.9 times 5.2 times cosine of 43. There we go. Is that what you're getting? If you're not getting that, I can help you. Okay, it's probably the way you have to type it in. So here we go. I'm writing this down. 29,361 ... Okay, and here you go. What do you have to do? While it's on your screen, you just press the root button and hit equals. And that's your answer. 5.42 if you round correctly. And that's centimeters. Okay, 5.42 centimeters. Does it make sense? It is within our numbers that we're given, right? Could you use sine law now? If you think about it, you have a pair now, right? You've got this side. So some students turn into sine law after, and they just go with sine law from here on in. No problem, you go for it, okay? I'm not going to argue with you on that one. Your answers will be slightly different because of rounding, but don't worry about it. Can you practice this right away on 17? Go to 17 and practice this. I'm going to come around and actually see if you're doing okay with the calculator. And then we'll continue with the SS. I'm just going to walk you through one more because there's a problem here. This is obtuse, right? Do you know what obtuse is? Bigger than 90? Okay. Can I just ask you to grab your calculator? I need you to be aware of this. Cosine of 91. Type that in. You get a negative. Let's do cosine of 89. Right? Cosine is 89 is just on the acute side. You get a positive. What about cosine of 90? You tried it already, eh? At 0. Cosine of 90 is 0. Okay. So what I need you to be aware of is if there's an obtuse angle, there are two negatives that are going to collide. But if you do it my method, you don't have to worry about it. So to solve for r, make sure you square it. We take the other two sides. And it doesn't matter which one you write down first. It really doesn't. It's like 2 plus 3 or 3 plus 2, same answer, right? Then you go minus. What is important is that you go plus, minus, and then it's 2 times the first side you wrote down. That's what I do to help you remember. Times the second side. All of that times cosine of 91. Okay? If you do this all in one shot, you get 61.715 ... which is 7.86 kilometers. However, I would like you to write this down if you can. If you packed already, I don't blame you. You want to get out of here. But look at what's going to happen here. If I multiply just this part here, it's going to give me a negative 0.9755 and so forth. These two negatives turn into, yes, because they're multiplying, turned into positive. So if you do this in steps, you have to go this plus that, whatever you get here. But if you do it my method, you have nothing to worry about. You don't need to really worry about this. It's only for students that break it down into pieces where you do have to worry about that, okay? We're going to do side, side, side tomorrow. Be ready to do one of these as an AC, just a short warm-up, okay? And then we're going to continue with word problems. We're going to mix it up.